Hey everyone, this is Big Face from Big Face Robotics, back with an update on the Big Wheel bot. I realise it's been a little while since I've uploaded a video, and that's because I've been working hard on the software for the robot. You'll see a couple of hardware changes. I'll discuss them in a minute. You'll remember from the end of the last video I was looking at visual odometry techniques and structure from motion and that sort of thing, and I've been playing around with that and had some success. I managed to calculate camera positions and how the camera had moved between frames and triangulate some points, and that's what you're seeing on the screen now. And that was good fun. I learnt quite a lot. But after working on that for several weeks and reading a lot about it, I've decided to change direction a little bit with the software for this robot. So keep watching this video because I will touch on some of the techniques and I've managed to make some progress with the robot. But what I decided to do was go back to basics a little bit and have a think about navigation techniques that I could use. And one thing that inspired me was hanging out in the garden and watching the insects navigating and busy doing their work. And it got me thinking about how they managed to navigate around. Now this isn't new, people have been studying this for many years and trying to apply it to robotics, but I thought I'd have a go myself at coming up with a few techniques that might be useful. So to facilitate that, there's a couple of minor hardware changes to the robot. You'll notice the robot arm has gone in favour of a pan tilt assembly. I took this off of a robot I built previously, a sort of desktop head robot, and I've repainted it to make it look a bit nicer on the robot. I've added some bigger spacers to get the camera up above the wheels, and now this can pan 180 degrees. And the idea is to capture images from around the robot as it moves around. I've also popped the sonar on the front just for obstacle detection. So the main thing I've been working on is the software. I've been trying to get the robot to move around autonomously using the remote control. That was all well and good, but it's not really a robot unless it's autonomous, I don't think. So what I've been using is the data coming from the IMU, which is now tucked back inside the robot body. So I didn't really need it mounted up with the camera anymore. And I've been working on getting the robot to turn to face a particular heading as measured by the yaw value coming from the IMU, and to have the robot drive in a straight line, again tracking a set yaw value using the IMU, and I managed to get that working. Took a little while to get it set up and working as it should, and plenty of tweaking of PID loops to get it working reliably, but it's doing what it should. Still not perfect, the driving in a straight line still isn't perfect, but it's getting there and it's good enough now to move on to the next stage. The other interesting technique I'm trying is I did build some encoders for the drive wheels, and I wasn't particularly happy with them. I got a thing about encoders. I'm not a huge fan of them. I could go and buy some or make some, but I thought I'd try something different instead, and something that might be applicable in the future to a walking robot or something that hasn't actually got wheels. So I thought I'd try some new techniques, and that is actually using the camera looking at the ground in front of the robot to measure the distance that it's travelled. And given that the camera height and angle are fixed on this robot, it removes a lot of variables from standard sort of visual odometry where you're trying to calculate camera positions between frames. I don't need that complexity because the camera is always a fixed height and an angle. So that's what I've been working on. I realise that this is going to be a bit of a challenge and might not work, or might take quite a lot of effort to get it to work, but early tests are promising and I'll show you some of them. So experiments with the visual encoders. I captured some footage as the robot was driving around and the camera was pointing down at an angle probably a bit less than 45 degrees, something like that. And I was trying to drive the robot in a straight line as accurately as I could, about 1 metre. So that's what you're seeing on the screen here, the various trials that I did out in the garden. And what I'm doing is grabbing the orb features from each consecutive frame of video, and I'm matching them and then working out the average of all of the matches, and then I'm converting that to an average distance in pixels that the camera has moved, or that the features have moved in the image. I then use a calibration factor to roughly convert that to a millimeter reading, and that's what you're seeing here. And I ran 7 or 8 different trials, and all were within 50 to 60 millimeters, which I think is fairly accurate considering my rough measurement as the robot was driving. Okay, so here's the current setup for testing the visual encoders. So what I'm trying to do is measure the distance the robot travels using just the webcam, looking down at the floor in front of the robot. And I've got my little test set up in here, and because the carpet doesn't have much texture for the robot to pick up on, unlike grass and the footpath outside, I've put down these sort of tape markers so the robot camera has got something to pick up on as it drives along. So I've got this set up for a test where the robot is going to drive forward hopefully 1 meter and then stop, and then we'll measure to see how accurate it is. I've done a few tests and I've had to dial in the calibration settings, but I'm going to run another test now and see how it gets on. So I'm just going to measure this one. So the robot started pretty much centered on that black line there, and you can see where it stopped just a little bit past a meter. So as a proof of concept, this does seem to work, and I can measure reasonably accurately the distance that the robot's travelled. Okay, so one more little tweak of the calibration settings. See if this is any more accurate. There we go, the robot didn't quite maintain its sort of straight line, but it's really close to the 1 meter mark, which is good. So I do think this the accuracy can be adjusted till we get a satisfactory result. So going back to the robot working autonomously, I've been working on the Arduino and Python code for this. And I'm at a stage now where I've programmed a scan, so the camera will move to certain positions and capture images, and the robot will turn to face a given angle or turn by a given angle and scan again. So that's what's showing on the screen now, and that seems to be working nicely. There we go, that's the update on where I am. So I've got the visual encoders, as I'm calling it, kind of working. So the robot can measure how far it's driven. I've got control of the direction of the robot using the IMU, and driving in a straight line almost working. And I can also scan with the pan tilt and capture images at various points in the robot's journey. So I need to now bring all of this together to program a sequence of movements or some sort of exploration routine. So the robot will drive, turn, whilst avoiding obstacles using the sonar sensor. And at various points in that journey, stop and collect images at different directions using the webcam. And the idea is to use techniques similar to what insects might use in their navigation, of comparing the images captured to try and recall and plan a path back to a goal or back to the home position. I'm not sure how well this is going to work. This is very early days and this is experimental sort of stuff, but based on what I've been doing and experimenting with, it has potential, and if nothing else, it's very enjoyable to do. So I'm going to leave it there for this video and come back soon. I'll continue working and hopefully I'll have something interesting to show you in the next video. Please consider liking and subscribing to this video if you enjoy the content, and as always, thanks for watching.